The aims of this experiment are to observe displacement reactions among metals and metal ions, to arrange metals in a series based on the increase in order of their reactivity, and to determine the relative positions of metals in the electrochemical series. The activity series is a ranking system of metal based on the ease with which they are oxidized. The activity series is set out from high reactivity metals to low reactivity metals as shown here. A metal with higher reactivity oxidizes to reduce a metal ion with lower reactivity. For example, let's consider the reaction between magnesium and copper sulfate. Here, the magnesium in the top of the activity series oxidizes to magnesium 2 plus and copper 2 plus in the bottom of the activity series reduces to copper metal. The chemicals required for this experiment are 1.0 moles per cubic decimeter copper sulfate, ferrous sulfate, sodium sulfate, lead nitrate, zinc sulfate and magnesium sulfate. In addition, iron, magnesium, copper, lead and zinc are required for this experiment. The laboratory equipments required for this experiment are measuring cylinders, spatula and test tubes. Next, let's see how this experiment is performed. First, let's see how copper metal reacts with each salt solution. First, add small pieces of copper into 6 test tubes. Next, add 5 ml of salt solution to each test tube. First is the magnesium sulfate salt. Next is the zinc sulfate salt. This is the lead nitrate salt. Next, let's look at the reaction with ferrous sulfate. Next is the sodium sulfate salt. This is the copper sulfate salt. After 10 minutes, it can be observed that the copper metal has not reacted with any salt. As before, the magnesium metal has been added into the test tubes. Next, let's see how magnesium reacts with each salt solutions. Here, it can be observed that some reaction takes place between magnesium and lead nitrate. Here too, we can observe a reaction with zinc sulfate. Next, let's see how magnesium reacts with copper sulfate. Here we can observe a reaction. It can be observed that there is no reaction between magnesium and sodium sulfate. This is the reaction with magnesium sulfate. There is no reaction here. Here we can observe a reaction with ferrous sulfate. Next, let's see how lead reacts with each salt solutions. There is no reaction between lead and sodium sulfate. This is the reaction with ferrous sulfate. There is no reaction here. It can be observed that no reaction occurs between lead and magnesium sulfate. There is no reaction between lead and lead nitrate. With zinc sulfate, there is no reaction. Let's see how lead reacts with copper sulfate. We can observe a reaction here. Next, let's see how iron reacts with each salt solutions. First is the reaction with sodium sulfate. There is no reaction here. Let's see the reaction between iron and ferrous sulfate. Here there is no reaction. Here too there is no reaction with magnesium sulfate. In the reaction between iron and copper sulfate, a copper color solid is deposited on the metal. Here there is no reaction between iron and zinc sulfate. This is the reaction between iron and lead nitrate. We can observe a reaction here. Next, let's see how zinc reacts with each salt solution. There is no reaction with sodium sulfate. It can be observed that some reaction takes place with ferrous sulfate. There is no reaction between zinc and magnesium sulfate. This is the reaction with zinc sulfate. Here too there is no reaction. Let's see the reaction between zinc and lead nitrate. It can be observed that some reaction takes place here. Let's see how zinc reacts with copper sulfate. A copper color solid is deposited on the metal. The observations of this experiment are given in this table. Here, NR indicates the no reaction between metals and metal ions. According to these observations, a copper color solid is deposited on the metal during the reaction between iron and copper sulfate and during the reaction between zinc and copper sulfate. This deposited solid is copper metal. Let's consider the reaction between iron and copper sulfate. Here, iron oxidizes into iron 2 plus and copper 2 plus reduces into copper. This copper deposits on the metal. The same thing happens with the reaction between zinc and copper sulfate. Other reactions between metal and metal ions are also displacement reactions, but metals deposition cannot be observed in other reaction mixtures as the observations are taken within 10 minutes. When these reaction mixtures are kept for several hours or a day, it can be observed that the metals formed by the reduction of the metal ions are deposited. Among the metals used in this test, magnesium reacts with most of the metal ion solutions. Among the metals used in this test, copper reacts with a small number of metal ion solutions. According to the reactivity of metals used in this test, we can arrange these metals from the most reactivity metals to least reactivity metals as magnesium, zinc, iron, lead and copper. Since there is no reaction between magnesium and sodium sulfate salt, it can be concluded that sodium metal is more reactive than magnesium metal.